Go.
You might want
Hi everyone, today I'm going to present one of my PhD research work in which we are trying to reduce the electricity cost for data centers by migrating the virtual machines. Before I go into the presentation, first I should clear up the concept of virtual machines. So when we see the desktop and laptops in our home or workspace, these are physical machines because every work is done on the physical hardware that we have here. But in data centers or big commercial deployments of computing services, they tend to have these big servers which has these virtual machines where they can cut down the computing powers to multiple users, so it's easier to manage and it's cost efficiently. So the concept of cloud is mostly based on these virtual machines. So we are using this migration of virtual machines to reduce the electricity cost in data centers. So first I'm going to go over how the electricity market works and how we are exploiting that for the purpose of our research. And then I'm going to go a little bit over how the VM migration works and how the consumption of electricity in data center works and what we are trying to solve in this particular research problems. So the idea comes out of the data centers that mostly all the big companies have: Google, Facebook, Microsoft. Everyone has their own data centers, and the electricity cost of the data center is really high, as you can see with the very large data centers from Google. It's almost 40 million per year. The MIT campus is not really an example of data center, but it's a big enterprise network where there are lots of nodes and connected network devices. Even there, the data center cost is the computing and networking cost is not that low. It's $62 million per year. So it's a very good motivation for us to work towards reduction of the electricity cost. To understand how we're doing this, we look into the electricity market, and electricity market is divided into different ISOs. These service organizations provide their own electricity price, and they have their own demand and price combination. So let's say in the morning, if in Virginia the electricity price is really low, that doesn't mean that in California it will be low. Probably it's higher in California, and vice versa, depending on the time and the place. So there have been studies that shows that how the electricity price correlates between the time and the space. As you can see in this figure, in the morning, the electricity price was really low in the ERCOT, that's the Texas ISO, and let's say around in the 7 a.m. the lowest is in California. But if we look into the 6 p.m. in the evening, the California goes really high, and the lowest price is in New England. So using this variation, there have been studies that shows that if you have multiple locations of data centers, you can choose where to run the computing request that comes from the users. So users logs into their system and requests some service from the, let's say, Google or Facebook, and Google and Facebook runs that query, runs that request in their own virtual machines, right? So Google has the choice to choose where to run that request so that it has the lowest operational cost in terms of electricity. So from there, we have two portions of this solution that we are providing. The first one is when the initial request comes in, we have the choice to place it in either in California data center or in Virginia data center. But once the user has logged in and the request is already running, and the electricity has changed in the next hour, we wish that we could do something about the already running VM and the service that that it's serving. So there are ways to migrate the already running VMs in one data center to another data center. The technique is called VM migration, as intuitive as it is. So if there is a network connectivity, we can use the migration technique to reduce electricity cost by serving the service in the lower cost data center. So that actually summarizes our problem statement and what we are trying to achieve. And from the end results we see, depending on the workload the data center is expecting, we can save up to 32%. And in case of extreme workloads, we can save up to around 11% of the electricity cost. Thank you. Any more questions?
Why not have these data centers in other countries? I think it could be much more cost effective. For example, having these data centers in India or China or Mexico.
Yes. This is a good point of view. So we can place data centers in outside USA, but there are two constraints. One of them is there are privacy and data related laws that prevents you to take the user data out of the country. Another thing is the delay and the response for the users will increase when you move the data center too far away. So that's another problem that we have to keep in mind. Any more questions?